students. Today in this video we are going to complete hybridization. Okay. In the last video also we have discussed half part of this table, and now and the next example it is if 5 bond pair of electrons are there. If 5 bond pair of electrons are there and the number of lone pairs are 0, then bond pair plus lone pair of electrons is equal to 5. And here what is the hybridization if it is 5? So here it is hybridization is sp3d. 1 plus 3 plus 1. 1 s orbital, 3 p orbitals and 1 d orbitals. So now what is the geometry? If the bond pair of electrons and lone pair of electrons are 5, it is trigonal bipyramidal. It is trigonal bipyramidal. So what will be the geometry? It is trigonal bipyramidal and it will be like this. Triangle. Here will be central atom and here these are the surrounding atoms. Bipyramidal. You assume this as a triangle. My hand is a triangle. One atom is above the plane like this and another atom is below the plane. Here, so here another atom. So the best example here, if the lone pair of electrons is equal to 0, geometry will be equal to shape. So what is the shape? Same trigonal bipyramidal only. So now the examples for this one are PCl5 and PF5. So here you are given with a question. So PF5 or PCl5 and asked you to find out hybridization or geometry or shape, whatever it may be. Now you adopt the procedure what I have given to you. So here PF5 phosphorus, it belongs to 5th group. So 1, 2, 3, 4, 5 cross marks and 5 fluorine atoms. So here 5 bond pairs. So here 5 bond pairs and 0 lone pairs. So here it is the hybridization sp3d as the lone pair of electrons is equal to 0. And the shape is equal to shape will be equal to geometry. Okay. So similarly you can calculate for PCl5. So this is the procedure. Okay. Clear? Then if bond pair of electrons are 4 and with a 1 lone pair. With 1 lone pair. So now I'll clear this one. So if lone pair is 1, now bond pair plus lone pair is equal to 5. What is the hybridization? Same sp3d hybridization. And what will be the geometry? Geometry is as usual, it is a trigonal. If it is 5, it is the central atom. 1, 2, 3, 4, 5 atoms. Same geometry is trigonal bipyramidal geometry only. Now here 1 lone pair is there. Now the problem is where to keep this lone pair. So here if 1 lone pair is there, where to keep this lone pair? So first examples for this one, here SF4, TeCl4. These two are the examples for this with the molecule with 4 bond pairs and 1 lone pair. Now here I told you this is an axial position and these are the equatorial position. Here these are the equatorial positions. Equatorial position. These are axial position. One above the plane and another below the plane. Now here where to keep this lone pair? Write again. Here two possibilities, either to keep on the axial position or to keep on the equatorial position. So here equatorial position means like this. So here lone pairs are present. If the lone pairs are present in the axial position, that molecule undergoes more repulsion and here it is less stable. The molecule will be, if at all, the lone pair occupies axial position, the molecule is less stable. But here, if the molecule occupies, means if the molecule, if the lone pair of electrons occupies the, I told you here lone pair repulsions are greater than lone pair bond pair repulsions, which is greater than bond pair repulsions, isn't it? So here, if the lone pair of electrons occupies the equatorial positions, it undergoes less repulsions. When compared to this will be more stable. So now here, where this lone pair will occupy the equatorial position, so S, F, 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 SF4. Now calculate hybridization for SF4. Sulfur, it belongs to oxygen family. Oxygen, sulfur, selenium. So here 6th group, 1, 2, 3, 4, 5, 6th group, 4 bond pairs because 4 fluorine monovalent atoms, 4 bond pairs and 4 bond pair of electrons with 1 lone pair of electrons. So altogether 5 sp3 dehybridization. Geometry is trigonal bipyramidal geometry, but the shape is, because of the lone pair which occupies the equatorial position, the shape is seesaw structure. So I told you, no, please don't consider this lone pair part. So this is called as the seesaw structure. So SF6 and T is for similarly for TeCl4 also you calculate the hybridization, and that will be like a practice for you. Clear? Okay. Now 3 bond pairs, 2 lone pairs, altogether 5. Again sp3 dehybridization, and the geometry is again trigonal bipyramidal. Now what will be the shape? So here again I am writing this one. So here the examples are ClF3 and BrF3. I told you, no, these two belongs to same group, halogen family, interhalogen compounds. We call them as interhalogen compounds. So here among these two belongs to same group. The atom with less electronegativity will become the central atom. So among chlorine and fluorine will be the central atom. Okay. And now calculate the hybridization. You follow the same procedure. Chlorine belongs to 7th group, 1, 2, 3, 4, 5, 6, 7, and 3 fluorine atoms, 1, 2, 3. So 3 bond pairs. Okay, 3 bond pairs, 2 lone pairs. Okay, and altogether 5. So hybridization is sp3d and it is a trigonal bipyramidal geometry. Now here where to keep these 2 lone pairs. So as usually, what are the equatorial positions? This is an equatorial position, this is an equatorial position, this is an equatorial position. Where to keep these 2 lone pairs? Here we have, if one is there, you can keep this one, you can keep that lone pair here. So the structure will be like this, seesaw structure we call it as. So here 2 lone pairs are there. If 2 lone pairs are there, 2 lone pairs will occupy these 2 equatorial positions. Now you exclude the lone pair of electrons from the geometry. So what will be the shape here? T shape. T shape. What is the shape? Here there should be no confusion between geometry and shape. Geometry means it is bond pair of electrons and lone pair of electrons. Shape means here we exclude lone pairs. So here in this structure, you start from here. If it is BrF3, bromine belongs to 7th group, 7 cross marks and 3 fluorine atoms, 3 bond pair of electrons and 2 lone pair of electrons. Where to keep these 2 lone pairs? Here lone pairs will occupy the positions in such a way that there will be less repulsion, so that molecule will be more stable. So here if one is there, that will be seesaw structure. 5 bond pairs, you just repeat along with me. You try to assume if 5 bond pair of electrons are there, lone pair of electrons are 0, it is sp3d hybridization and the geometry is trigonal bipyramidal, means here it is a triangle, one atom above the plane and another atom below the plane. And here one lone pair, so geometry will be equal to shape. If it is no need to by heart anything, please. So here, no, if lone pair of electrons if lone pair of electrons are 0, geometry will become equal to shape. So here, and if one lone pair is there among this triangle, three parts of the triangle, this occupies the equatorial positions, because if it occupies the axial positions, more repulsions, the molecule will be less stable. So the molecules always try to lone pairs always try to accommodate in such a position, so that there should be less repulsions and more stable. So here, if one lone pair is there, here it will occupy the corner. If two lone pairs are there, it will occupy these two equatorial positions. If one lone pair is there, the structure is seesaw structure like this, because we exclude this lone pair. Okay, the structure will be like this. If two lone pairs are there, here they too occupy the equatorial positions. We exclude this position and the shape is T shape. You take any one example and you follow the procedure I have given to you, and you can calculate the hybridization, bond pair and lone pair of electrons, and the geometry and the shape. Clear? Now, here, okay, we'll move to the next one. Now, if three lone pairs are there, two bond pairs, a bond pair plus lone pair, 5, hybridization, sp3d hybridization, and the geometry, same trigonal bipyramidal geometry. Where these three lone pairs will occupy? Obviously, equatorial positions. What are the equatorial positions? This is the equatorial position, this is also equatorial position, and this is also equatorial position. Now, 1, 2. Okay. Now, examples for this one. XCF2, I3 minus, ICL2 minus. Here among this has asked many times. I3 minus. What is the hybridization and the shape of I3 minus? So here, first you calculate for XCF2. Xenon belongs to 8th group, noble gases. 1, 2, 3, 4, 5, 6, 7, 8, and 2 fluorine atoms. So 2 bond pairs, bond pair of electrons. 1, 2, 3. 3 lone pair of electrons, all together 2 plus 3, 5. It is sp3d hybridization. And here xenon is the central atom. I'll place xenon here. These 3 lone pairs occupies 3 equatorial positions, and here you exclude these lone pairs. And what is the shape here? What is the shape here? Fluorine atom, linear. So similarly, I3 minus. So I3 minus. So 3 atoms are here. First you calculate hybrid bond pairs and lone pair of electrons. So here also 2, if you calculate iodine, 1, 2, 3, 4, 5, 6, 7th group, and halogen, negative for negative charge, +1. So here remaining 2 iodines, because 2 bond pairs. So 1, 2, 3, 2 bond pairs, and here 3 lone pairs. So 5, altogether 5, sp3d hybridization. Here the central atom will be iodine itself. 3 lone pairs occupies the equator I, like this. Linear geometry with sp3d linear shape and trigonal bipyramidal geometry with sp3d hybridization. And for ICL2 minus also you can calculate. Iodine is the central atom. In these are also interhalogen compounds. 7 plus 1, 8. So 2 bond pairs, 3 lone pairs, 5 sp3d hybridization. Clear? Super clear. Okay. So you take any one of these examples and try to solve on your own. Okay. There is no need to by heart anything. Just you imagine these structures and you remember one point where to keep the lone pairs. Okay. Next one. Number of bond pair. Next bond pair of electrons are if bond pair of electrons are 6. Now bond pair of electrons are 6 and lone pair of electrons are 0 and bond pair plus lone pair 6 and hybridization. So if bond pair of electrons are 6, lone pair of electrons is equal to 0, hybridization it is sp3d2 hybridization 1 plus 3 plus 2 and the geometry I told you it is square bipyramidal or octahedral. This will be like this. Altogether bond angle 90 degrees. SF6 example. Sulfur belongs to 6th group. You can calculate 1, 2, 3, 4, 5, 6. So 6 fluorine atom, 6 bond pairs with 0 lone pairs and this will be the structure. You can write this as geometry. Here lone pair of electrons are 0, geometry will be equal to shape. So you can write this as octahedral. So square bipyramidal or octahedral geometry. Shape is also square bipyramidal or octahedral geometry. Next one, I'll clear this one. If here one pair of electrons are say 5 and lone pairs are 1, sp6, again sp3d2 hybridization. If lone pair is there, now the examples for this one are IF5, XeOF4. These two are the examples for this one. Third one. Yeah. So here iodine is the central atom. So you calculate 5 bond pairs, 1 lone pair. Altogether 6 sp3d2 hybridization. It is where to keep this lone pair? Above the plane or below the plane. And here the geometry is square pyramidal. Now square bipyramidal. Geometry is square bipyramidal geometry or octahedral geometry. And the shape is square pyramidal. You exclude this one, it is a square pyramidal. So the shape is, geometry is octahedral. Simply I am writing here. And the shape is square pyramidal. For XeOF4 also you calculate xenon 8th group 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 1 lone pair. 1, 2, 3, 4, 5, 6. Altogether 6 with 1 lone pair. Okay, 5 plus 1, 6. Same, square pyramidal. The shape is square pyramidal. And the geometry is octahedral. Sorry. Next one. Four plus 2, 6 sp3d hybridization and if it is sp3d2 hybridization, here what is the geometry? Geometry as usual octahedral. Now the example for this one is XeF4. So xenon 4 bond pairs and remaining 2 lone pairs you can calculate by adopting that same procedure. 1, 2, 3, 4, 5, 6, 7, 8 and 4 bond pairs, 2 lone pairs. So 2 lone pairs Here that lone pair occupy this position. So here it is Xe F4 as usual. Okay, and the shape is, now you exclude the positions of the lone pair. The shape is square planar. Clear? It is square planar. If the bond pair of electrons are 6 square bipyramidal, one square, you assume one square, above the square one atom, below the square one atom. If one lone pair is there, it occupies either upper position or lower position. The structure will become, the shape will become, geometry is same square bipyramidal, but the shape, but coming to the shape, it is square pyramidal. And next, if two lone pairs are there, two lone pairs occupies the upper position and the lower position, and it is a square planar geometry. Okay. Now, if the bond pair of electrons are 7, we have come to end of this topic. So lone pairs are 0, bond pairs plus lone pairs is equal to 7. sp3d3 hybridization, 1 s orbital, 3 p orbitals and 3 d orbitals, and the geometry is, it is, I told you, pentagonal bipyramidal. Best example for this one is IF7. So iodine interhalogen compounds, iodine belongs to 1, 2, 3, 4, 5, 6, 7. 7 fluorines, 1, 2, 3, 4, 5, 6, 7. With 7 bond pairs, 0 lone pairs, and the structure is pentagon. I, F, 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 F. One atom above the plane of the pentagon, it is F and it is F. Pentagonal bipyramidal with a bond angle of the pentagon, it is 72 degrees, and one atom, you assume similarly for trigonal bipyramidal also. I have told you, assume this as a triangle, one atom below the plane of the triangle, another atom below the one atom above the plane of the triangle, another atom below the plane of a triangle. For square bipyramidal or octahedral also, you assume this as a square, one atom above the plane, one atom below the plane. Okay, in accordance with that, you place lone pairs. I told you, no, where there are less repulsions. And here if it is a pentagon, you assume this as a pentagon, same your hand, it is a triangle and it is a square and it is a pentagon also. Okay, so if, on this pentagon, one above this pentagon, one atom is there, one atom below, one atom above the plane. So here one atom above the plane, one atom below the plane, means here it is perpendicular to the plane of the pentagon. So here the bond angle, another bond angle is 90 degrees. Okay, IF7, it is the best example for this one. With this we have completed hybridization. Here if you look at these videos, here I have covered each and every single point, so that this will be more clear to you. Okay, I'll come up with the next topic from the chemical bonding and the molecular structures only. Okay, till then, bye.